Okay, welcome back. This is page 80, problem 74. This is a sister problem to two problems in your assigned homework 6. I think they're 73 and 75. And this problem gives the function h of x, as I've got listed down, and it says find the average rate of change over 0 to 3, and then find the equation of the secant line containing the endpoints at x equals 0 and x equals 2. So just for a moment, let me quickly sketch this curve. At x equals 0, if I put 0 in, you see that I get 0 plus 0, I get 0. So the origin is a point on this curve. I'm drawing this, I can see that I'm drawing this a little odd. And if I put 3 in, I get 3 squared is 9 times minus 2 is minus 18 plus 3 is minus 15. So I'm just going to pretend that this is the point 3 minus 15. This is the point 0, 0. And then this curve h is clearly quadratic, so I get a curve that looks something like that over this particular domain. This is h of x. Okay? Good enough. What the problem wants you to do is find, on average, how the function changes as it goes from here to here. It goes from a value of 0 on the left side to a value of minus 15 on the right side, and it does so over a space of 3. So the average, just quickly, the average rate of change is minus 15 over 3, or minus 5. If you were to do that with a difference quotient, you would set up, and not f, in this case it's h of 3 minus h of 0 all over 3 minus 0. And we've sort of done that. We've said h of 3 is minus 15. We've said h at 0 is 0. 3 minus 0 is 3. At the end of the day, I get minus 15 over 3. I get minus 5. Right? And that is the average rate of change over the closed interval from 0 to 3. Now the second part of the problem, says let's find the equation for this line. I'm going to just draw a line segment, and then I'll kind of carry it on and say here's a line where the line contains this secant, the straight line segment between the left point of h and the right point of h over this interval from 0 to 3. So what this problem is trying to get you to recognize is that this average rate of change is also the slope of this segment. So the slope here is minus 5. And I've got a point. So very quickly I can just use the point slope form. Which says y minus y0 is equal to m times x minus x0. I'm going to pick this point right here, 0, 0, to be xy. So I'm going to say x0, y0 is equal to 0, 0. And m, the slope, is equal to minus 5. And I'm going to just immediately write down the point slope form. Specifically for this case is y minus y0, which is 0, is equal to m, which is minus 5, times x minus x0, and x0 is 0. And there's the equation. So again, this problem is trying to reinforce the idea that the difference quotient is the average rate of change, and the average rate of change also happens to be the slope of the slope of the secant segment. All right, thanks a lot.